Now let's take a look at Okun's law, which is a law describing the relationship between the output growth rate and the unemployment rate. It turned out that the law says that there exists a negative relationship between unemployment rate and the output growth rate, and the equation is shown as the equation 3.5. The y bar can be the full employment output, and then the y is the actual output, and then the u is the actual unemployment rate, and the u bar is the natural rate of unemployment. This equation then tells us that there exists a negative relationship between the output relative to the full employment output versus the changes in the unemployment rate away from the natural rate of unemployment, which is the cyclical unemployment rate. And then the ratio is by 2. That is, if the cyclical unemployment rate increased by 1%, then if the unemployment rate increased by 1 percentage point, then it means that the deviation from the natural rate of unemployment rate increased by 1 percentage point. And then it will imply that the output will decrease by 2 percentage points. So then in here it tells us when the cyclical unemployment rate increased by 1 percentage point, then the output deviation from the full employment level should decrease by 2 percentage points. So then once we assume that the natural rate of unemployment remains fixed and the full employment output level remains fixed, then the changes in the cyclical unemployment rate and the deviation from the full employment output becomes the changes of the unemployment rate and the output growth rate. So then we can derive the other form of the equation, which says that the growth rate of the output equal to 3 minus 2 times of the changes in the unemployment rate. And the 3 is the average growth rate of the full employment output in the US. Once we made this assumption, then we can plug it in the equation 3.5 and then derive the equation 3.6. So then what I want to do next is that I want to show you the Okun's law relationship in graph, and then I want to derive equation 3.6 from 3.5 later on. So then how does the Okun's law look like in graph? It turned out that if we plot the changes of the unemployment rate and the growth rate of the GDP for US from the 1950s to the 2000s, and then we will be able to come up with the negative relationship between the output growth rate and the changes in the unemployment rate. So then how to derive equation 3.6 from equation 3.5? So now let's rewrite equation 3.5, and then we will be able to plug in the date for the variable that allow to change over time, which is output and the unemployment rate. So at time t plus 1, equation will become equation 1. If it is at time t, then the equation will become equation 2. And then we can subtract equation 2 from equation 1, and then we are going to have yt plus 1 minus yt over y bar equal to minus 2 multiplied by ut plus 1 minus ut. So obviously when we subtract equation 2 from equation 1, the full employment output level y bar and the natural rate of unemployment rate u bar got cancelled out. So then if we rewrite the equation, for the left hand side of the equation, that is yt plus 1 minus yt over y bar, then it approximately equal to the changes in the y over the level of the full employment output equal in the right hand side, which is minus 2 multiplied by the changes in the unemployment rate. Then given that the changes in a ratio equaling the changes of the numerator minus the changes of the denominator, so then the left hand side of the equation in here can be converted into the changes in the y minus the changes in the full employment output level, and then the right hand side still equal to minus 2 multiplied by the changes in the unemployment rate. So then, given that in data the changes in the full employment output equals 3%, so then we can plug it in. And then we are going to have changes in the y equal to 3 minus 2 times of the changes in the unemployment rate. So then in here we derive the equation 3.6 from 3.5 based on the US data from the 1950s to the 2000s. We plug it in, and then that is exactly the relationship we see in data. So this completes the lecture for today.